So in the given problem, the open loop transfer function, that is g of s of the system with the unity feedback, is given by g of s. Here the h of s value is a feedback, so h of s value is 1. That is equal to 10 divided by s into 0.1 s plus 1, and the input signal to be applied to the system is given by r of t, that is equal to a naught plus a1 of t plus a2 divided by 2 t square. Determine the steady state error of the system. So first we need to find all the error constant. Suppose to find first all error constant. So first if you position error constant is nothing but kp, that is equal to limit s tends to 0 g of s. So formula. So if I limit s tends to 0, g of s is 10 divided by s into 0.1 s plus 1. Okay. So if I substitute s to this equation, I will get 10 divided by 0 is infinity. Right. So similarly, I need to find the velocity constant. So the velocity constant is nothing but your kv, that is limit s tends to 0 s into g of s. So limit s tends to 0 s into 10 s into 0.1 s plus 1. So here s get cancelled out. So if I substitute 0, so I will get 0 plus 1, that is equal to 10 as your answer. So here it is represented in terms of 1 by seconds. Okay. Generally they are constant units. So next acceleration error constant. That is mentioned as Ka, limit s tends to 0 s square g of s. So that is equal to limit s tends to 0 s square 10 divided by s into 0.1 s plus 1. So here s get cancelled out. So if I substitute s is equal to 0. So if I take s divided by 10, so if I take s constant, I will get 1 divided by s. So anyway, I'm going to get the answer as 0. Next, I need to find the steady state error constant. So here the input is a naught. Okay. So if the input is a naught, it is nothing but a position error constant. So I can give the cs is equal to a naught is my amplitude divided by 1 plus kp. Okay. So a naught divided by this amplitude value. 1 plus kp is 1 plus infinity. Okay, 1 plus infinity. So it is nothing but 0. Okay. So similarly for a1. So here a1 is nothing but a velocity constant. So a1 divided by kv. So that is nothing but a1 divided by kv value is 10, right? Next one is ES is the input is A2 divided by 2 into t square. There's nothing but an acceleration constant. So A2 divided by 2 into Ka. Okay. So it is nothing but A2 divided by 2 into 0. 2 into 0. it is nothing but your infinity. Since the ESS is total of this one, so 0 plus A1 divided by 10 plus infinity, I'll get the answer as infinity. Now let me go for the second problem. The question is the open loop transfer function of an unity feedback system is g of s is equal to k divided by s into 1 plus 0.025 s, and the damping ratio is equal to 0.4, and determine the value of k and the steady state error for the ramp input. Okay, here the unity feedback h of s is equal to 1, and the characteristic equation is given by 1 plus g of s and h of s is equal to 0. So, since h of s is 0, 1 plus g of s is 1 plus k divided by s into 1 plus 0.025 s, that is equal to 0. So, if I multiply s into 1 plus 0.025 s plus k, that is equal to 0. So, I'm going to multiply s. So, if I multiply s, I will get s plus 0.025 s square plus k is equal to 0. So, this is equal, this, if I divide the whole term by 0.025, I will get the answer like this. Okay, so this equation is similar to s square plus 2 damping ratio omega n s plus omega n square is equal to 0. This is my characteristic equation for the second order function. So, omega n square is equal to k divided by 0.025, and 2 damping factor omega n is equal to 1 divided by 0.025. Since they have given the damping factor is equal to 0.4, so 0.8 into omega n is equal to 1 divided by 0.025. So, omega n is equal to 1 divided by 0.025 into 0.8. So, I get the answer as 1000 divided by 25 into 8 into, so you get 400 divided by 8. So, it is nothing but it is not 1000, it is 10,000. So, you will get the omega n is equal to 50. So, you substitute in the other equation in order to get the value of k. Okay, so what is the value? 40k is equal to omega n square. So, k is equal to 50 into 50 divided by 40. So, 0 and 0 get cancelled out. So, 250 divided by 4 is nothing but we will get 62.5. This is the value of k. And what is the next question? They have asked to find the steady state error constant. So, in order to find the steady state error constant for ramp input, so we know kV is equal to limit s tends to 0, s into g of s into h of s, the h of s value is 1. So, I will get limit s tends to 0, s, and the g of s value is k divided by s into 1 plus 0.025 s. So, here s get cancelled out. So, if I substitute, I will get the value of is equal to k. K is something like 62.5. That is the value of kV. Okay. So how to find the ESS at a steady state error? So, the constant. So, I'm going to take it amplitude as 1. Okay, divide by kV. So, that is 1 divided by 62.5 is your answer. Thank you.